Hello, in this video I'm going to provide you the solutions for question 1 in tutorial 7, which is a topic of the first law of thermodynamics in open systems. So this is the first question. So the first question provides some data referred to an open system. So we have an inlet, we have an outlet, and you can see we have a list of data here. Okay, so if you have a look at the subscript of 1, so this is normally referred to the inlet, and the subscript 2 refer to the outlet. Then we have mass flow rate, which is m dot in a unit of kilogram per second. So this gives us the information that this is an open system. Assuming a steady state condition means that the mass flow rate at the outlet and at the inlet are exactly the same. So we need to calculate the flow area at the inlet and the specific volume at the outlet. So in this question, we're just going to use a formula in the formula sheet. Okay, so for an open system here, so these two equations are exactly for open system. Okay, so this one, mass flow rate. So the mass flow rate is equal to density times area times c. So in this module, c stands for velocity. Okay, and it is equal to a times c over divided by v. So this is a lowercase v, and this v, okay, this v is not for velocity. Okay, so you need to make a difference between these c and v. And so here v is a specific volume. Okay, so we're going to use this equation to calculate the flow area in the inlet and the specific volume at the outlet. So first of all, we can write m dot, which is equal to a1 c1 divided by v1. Okay, if we have a look at all the variables here, okay, m dot has been given, v1, c1, okay, m dot, c1, v1, so a1 actually has not been given, a1 here, so this is exactly what you needed to calculate. So calculate the flow area, so that's a at the inlet, so that's a1. Okay, so that we can calculate a1. So we just need to arrange it. So we can multiply by v1 at both sides. So we get m dot times v1 divided by c1. Right. So m dot is 1.2. So that's in SI base unit. v1 0.0305 over c1, which is 147 meters per second. So if we calculate that, because we're using SI base unit for each term, this will give us the SI unit for the area, which is meter squared as well. Okay, and okay, so if you like, you actually can convert this to centimeter squared by times 10 to the order of 4, so that's 2.49 centimeter squared. Okay, so if there's no requirement in the question, so you can use any actually. However, if you see anything like calculate the flow rate, flow area at the inlet in the unit of centimeter squared, and then you must convert that to centimeter squared, just as requested by the question. Okay, let's have a look at the second one. So because this is steady state condition, so we have m dot, which is equal to a2. So these are all at the outlet. Okay, at the outlet, so we know m dot, right? We know c2, we know a2. we don't know V2. So V2 is exactly what we need to calculate. So this is called a specific volume at outlet. So that's a V2. So V2 just equal to, and move V2 over here, and I'm just swapping, you know, m dot and the V2. So that's A2 C2 over m dot. Okay, so A2 here, 1.15, but be careful, that's in centimeter squared, so it's not SR base unit. So we need to convert that to square meter times C2, it's 116 divided by m dot. So m dot is the same, 1.2. And this will give us the cubic meter per kilogram, okay, which is SR base unit for specific volume, and you can calculate the value here, 0.1112. Okay, so in this question we just use the same equation here, okay, depending on different variables which have been given, and then we calculate the unknown variable.